Next, let's talk about measuring sound and how we measure sound. We discussed that almost all animals use sound in some way, but we need measurements in a way that we can quantify sound. So sound is the displacement of particles through a material, and there are several measurements that we can make. The first one might be amplitude. Amplitude is the height of the wave. How many molecules are being displaced at any given time? Amplitude corresponds to volume, or how loud a sound is. The more molecules that are displaced, the louder the sound is. The other measurement we spoke about is wavelength, what is the frequency between the waves. This is measured in hertz. You should be familiar with hertz from our discussions in electricity and how fast AC sound waves move. They move at 60 hertz. So hertz is a measurement of wavelength through molecules. Now, different molecules, different densities of material, right, carry sound waves differently. Air, the molecules in a gas are very far apart, and therefore the sound waves have greater resistance, right? There's more space that they have to travel before they can bump into the next molecule, right? So within a gas, the molecules are far apart, and so sound doesn't travel as effectively as it might in water. In water, in a fluid, the molecules are closer together, and therefore the sound waves, it's easier for them just to push against the adjacent molecule and create a sound wave. As we move into solids, such as a tabletop, right, sound moves very efficiently through a solid. If you put your ear to a table, a conference table, and then have a friend tap gently at the other end, you will hear that sound much more clearly than you will through the air. As you move into materials that are even more dense than wood, for example, steel, right, you can hear a train coming from miles and miles away, much further away than you could possibly hear it through the air. And if you've never made a string telephone, right, the string has greater density than the air and therefore actually conducts the sound more effectively than what the air does around. You can hear very clearly through a string telephone. It's a lot of fun. And so let's look at a little graph of this. So if we look at gases, carbon dioxide, air, and helium, the density of those molecules to one another correspond directly to their speed. So we can see that air is really pretty low down here. And in air, at sea level, the speed of sound is about 760 miles an hour, or 343 meters per second. As we move into water, we move to 1,500 meters per second, give or take. And seawater, since it's more dense than fresh water, is even faster than that. As we move into a solid, such as steel, you can see that in steel, sound waves are traveling a little more than 5,000 meters per second. The more dense the material, the faster the speed of sound. So that's speed, and I will see you again in a little bit.